Title: How Elevator Control Systems Manage Traffic, Safety, and Building Efficiency. Hook: When people talk about elevator performance, they often focus on two things. How many elevators does the building have, and how fast do they run? These are important, but they are not the whole story. In many office towers, hospitals, hotels, shopping centers, residential complexes, and mixed-use buildings, elevator efficiency depends heavily on the control system. A building can have several elevators and still suffer from long waiting times if the dispatch logic is poor. That is why a modern elevator control system is not just a device that moves the car up and down. It is the traffic brain of the building's vertical transportation network. What an elevator control system does: a modern elevator control system coordinates passenger calls, car position, travel direction, door status, speed feedback, load condition, safety signals, traffic density, and dispatch efficiency. Every day, a busy elevator system may process thousands of hall calls and dispatch decisions. Each decision affects passenger waiting time, travel efficiency, ride comfort, energy consumption, and long-term operational reliability. The controller receives signals from car operating panels, hall call buttons, floor position sensors, door interlocks, speed feedback devices, load weighing systems, safety circuits, encoder feedback systems, and inspection controls. After processing these signals, it decides which elevator should answer a call, which direction should be prioritized, whether intermediate stops are efficient, and how to reduce unnecessary movement. In busy buildings, these decisions happen continuously within fractions of a second. Why elevator quantity is not enough: many people assume that adding more elevators will solve traffic problems. Sometimes it helps, but poor dispatch coordination can still create congestion. For example, several elevators may repeatedly respond to lobby traffic while upper floor passengers wait longer than necessary, or one elevator may reverse direction too often because calls are not grouped properly. This is why elevator traffic performance depends not only on elevator quantity or speed, but also on control logic. Modern controllers must manage traffic as a system, not as separate elevator cars operating independently. Group control and destination dispatch in small residential buildings. A basic single elevator control system may be enough, but larger buildings usually need more advanced dispatch logic. Collective selective control processes, upward and downward calls separately. The elevator continues serving calls in its current travel direction, while opposite direction calls are stored until the direction changes. This reduces unnecessary reversals. In large commercial buildings, group supervisory control is more important. Multiple elevators are coordinated as one system. The controller evaluates car location, passenger demand, travel direction, car load, waiting time, and traffic density. Then it assigns each hall call to the most suitable elevator. This helps reduce unnecessary stops, empty running, and traffic imbalance between cars. Many newer buildings also use destination dispatch. Instead of pressing only an up or down button, passengers enter their destination floor before boarding. The controller then groups passengers going to similar floor zones into the same elevator. This can reduce intermediate stops, improve handling capacity, shorten travel time, and improve peak hour traffic performance. Destination dispatch is especially useful in high-rise offices, hotels, hospitals, mixed-use developments, and large commercial buildings. Access motion feedback and safety. Modern elevator control systems may also connect with access control. Passengers may use RFID cards, IC cards, QR verification, biometric access, or destination authorization terminals to reach authorized floors. This improves security, but it can also improve traffic efficiency because unnecessary or unauthorized floor calls are reduced. Motion feedback is another important part of the control system. The controller monitors car speed, motor rotation, floor position, door zone status, deceleration timing, and leveling accuracy. Accurate feedback helps the elevator achieve smooth acceleration, stable deceleration, precise floor stopping, proper door opening timing, and better ride comfort. Safety logic is also managed by the controller. Before allowing movement, the controller checks door interlocks, safety circuits, terminal limit switches, overspeed governors, safety gears, emergency stop systems, and buffer protection devices. If an abnormal condition is detected, the system may prevent startup, stop operation, trigger braking, activate alarms, or enter protection mode. The controller also manages inspection mode and fire recall. During inspection mode, elevator speed is restricted and normal passenger operation is disabled. During fire recall, normal calls may be cleared, elevators return to designated recall floors, and the system switches to emergency logic. Modernization. Many older buildings still use aging relay-based controllers or outdated dispatch systems. These buildings may experience slow dispatch response, unnecessary stops, inconsistent leveling, high maintenance complexity, and limited spare part availability. In some cases, upgrading the control system can improve elevator performance without replacing the entire elevator. Common modernization options include relay to LC conversion, microprocessor controller, upgrades, group dispatch optimization, encoder feedback integration, destination dispatch retrofits, traffic analysis improvements, and remote monitoring. This is why controller modernization has become important in many aging commercial buildings. Conclusion. Modern elevator control systems do far more than operate motors and doors. They coordinate traffic management, dispatch sequencing, motion feedback, safety monitoring, emergency operation, access control, and building efficiency in real time. Elevator efficiency is not only about speed or quantity. It depends on how intelligently the control system manages passenger movement. The main point is simple. The elevator control system is the traffic brain of the building. For more details, you can read the full article here. https://fitechnelift.com Feihao, elevator, control systems, manage, building, traffic. Efficiency. Fate.